Okay guys, last lesson we looked at square roots and powers. So for example, I said to you that if we have the square root of x to the power of 6, we look at x to the power of something squared will give us x to the power of 6. So we said we need to know what number goes in this gap. And in this case, we know that it's going to be 3. Because if you have a to the power of m raised to the power of n, you get a to the m times n. Okay, so to get to that 6, you need to do 3 times 2. Okay, so we know that our answer to the question for this one is going to be x cubed. Now, I also told you in the past that square roots are actually also a power. We didn't go any more into detail with that because we're going to do it now, but a square root is actually an exponent. Okay, it's not just a square root, it's actually an exponent. So what we're going to do is we're going to look at what that square root is as an exponent. Okay, so we said that the square root of x to the power of 6 is equal to x to the power of 3. But as I said to you, the square root is actually a power, it's actually an index. So we know that we have x to the power of 6, and that's being raised to the power of something. And we don't know what that is yet because we haven't learned it. And that's equal to x cubed. Now, looking at what we did over on the right, over here again, with your a to the power of m raised to the power of n, okay, we want to know in this case, what power needs to go here in order to get a 3 on the right. Okay, so if we want to do 6 times something gives us 3, what does that need to be? It needs to be a half, because 6 times a half is equal to 3. So what you can see from that is that the square root is the same as raising something to the power of a half. So x to the power of a half is the same as the square root of x. Okay, we're not going to do this in any more detail than this year. You'll do more of it in the future though. Okay, what that means is that if you have if you have the square root of x, you can write that as x to the power of a half. All right, now this will also be combined with your other rules. So earlier in the year we talked about if you have a to the power of m plus times a to the power of n, we have a to the power of m plus n. Okay, this works with square roots as well. So if we have, for example, x cubed root x, that's the same as x to the power of 3 times x to the power of a half. Okay, because the x to the power of 3, you already have that, and you know that the square root of x is x to the power of a half. So we can now write that as x to the power of, using this rule up here, this becomes x to the power of 3 plus 1/2, which is x to the power of 3.5. All right, now what we're going to be doing for this lesson is we're going to be writing things in the form of x to the power of something. So we want everything to look like x to the power of, say, m. Okay, and you've got to find that m. So let's do some examples together before we start. So the first one we just did one with x cubed root x. Now, you're going to need to remember all your index rules. We've done quite a few of them. So we had, as we already said, a to the power of m times a to the power of n equals a to the power of m plus n. We had a to the power of m divided by a to the power of n, and that's equal to a to the power of m minus n. We had a to the power of m raised to the power of n is a to the m times n. And we also had a to the power of negative m equals 1 over a to the m. And the converse of that is 1 over a to the negative m equals a to the m. These are what we're going to be using today. Okay, so if we want to write, for example, 1 over the square root of x as x to the power of something. Okay, this now uses two of the rules. We know firstly that this means we have 1 over x to the power of a half, okay, because that's the square root. Now we also want this to be x to the power of something. At the moment there's still a 1 there. We need that to go away. So for us to move the x back up to the top, we can make that power a negative. So this is using that last rule, okay? So we're going to write this as x to the power of negative 1/2. Okay, so that's another example. There's all kinds of other ones. So we could have x cubed root x to the power of 4. How can we write this? We can write this as, firstly, you need to remember that you've got to apply that 4 to both numbers inside the bracket. So we know that we now have x to the power of 3 times 4, okay, times x to the power of a half times 4. Okay, so we're going to have x to the power of 12 times x to the power of 2. And that's going to give us x to the power of 12 plus 2, which is equal to x to the power of 14. All right, these are going to take some practice. This is quite a lot for you guys to be doing in year 2. The important thing is that you try and do things one step at a time. So don't try and do too much at once. So again, we can do a few more examples just to make sure that you guys have seen the way to do some of these. So if I had x to the power of, or x squared root x divided by x cubed root x squared. Let's try this one. Okay, so again, do these in small steps. Just think about each thing one step at a time. So x squared can stay as it is. X squared is not going to change. Okay, the square root of x, we're going to write that as x to the power of a half. Okay, then we're going to look at the denominator. So you have to decide now which order you want to do things in. I would suggest that you firstly just deal with what's inside the bracket. So x cubed is going to stay as it is. And the square root of x is now going to be, again, x to the power of a half. And we are still going to square all of that. Okay, so now we're going to look at it again. So the top, we'll just keep it the same for the moment because I just want to look at what happens at the bottom here in the denominator. Okay, and we're going to divide that by. Now again, the 2 needs to be applied to both terms inside the brackets. Okay, so we're going to get x to the power of 3 times 2 times x to the power of a half times 2. Okay, so that becomes x to the power of 2 times x to the power of a half. Again, we're not going to change the top yet. We'll do that in a sec. Divided by x to the power of 6 times half of 2 is 1. So times x. Now we can look further at simplifying. So for the numbers at the top, that's going to become x to the power of 2 plus a half. Divide that by x to the power of 6 plus. Remember that even though we don't normally write it, there's an invisible 1 here. So 6 plus 1. So what we get is x to the power of 2.5 divided by x to the power of 7. Now that's still not finished because our term still isn't written as x to the power of something. We need to use that rule that we don't use super often, which is the division one all the way back up here. A to the power of m divided by a to the power of n. Okay, so this time we're going to subtract our indices. So we're going to have x to the power of 2.5 minus 7, which gives us x to the power of 4.5. And now we have it in the form of x to the power of something. We finished that one off. Okay, so this is working with fractional indices. Okay, so these are exponents that are written as a fraction. You're going to see these more and more, especially when you get into year 4. Year 4 is where this comes up a lot. It's in both types of maths in year 4. So it is something that you need to you need to get used to, really. These are just working with x though. Okay, so you are also going to have to work with numbers here. So if I said we have 1 over 8, and we want to write that as a power of 2 to the power of m, 3 to the power of m, or 10 to the power of m. We want to do them all like this. So 1 over 8, you've done this one before. That's the same as 1 over 2 cubed, which is the same as 2 to the power of minus 3. Okay, so if instead we say 1 over the square root of 8, okay, that is now 1 over 8 to the power of a half. Okay, so we don't really need the brackets there. So we have 1 over 8 to the power of a half. Now, we also said that 8 is 2 cubed, so we can write this as 1 over 2 cubed to the power of a half. Okay, and again, using that am to the power of n rule, it's a to the power of m times n. So we're going to have 1 over 2 to the power of 3 times a half. 3 times a half is 1.5. So we have 1 over 2 to the power of 1.5. Now, this is still not in the form of 2 to the power of something. We need to move that to the top. So again, we need to make the power negative to move that up. So this is going to be the same as 2 to the power of minus 1.5. You could also write this as 2 to the power of minus 3 over 2. If you find the improper fractions tidier, which personally I do, you know that, but if you find the improper fractions nicer, then feel free to write them that way instead. Okay, just be careful. So sometimes the hard bit is just looking for what your base number is, but you know that if it's 2, 3, or 10, it's going to be one of these numbers. Okay, so you need to try those out. Find out, maybe make a list of your 2 squared equals 4, 2 cubed equals 8, 2 to the power of 4 equals 16, 2 to the power of 5 equals 32, etc. You know that 3 squared equals 9, 3 cubed equals 27, 3 to the power of 4 equals 81, 3 to the power of 5 equals 243. And for the 10s, it's easy because you just know 10 squared is 100, 10 cubed equals 1000, 10 to the power of 4 equals 10,000, and 10 to the power of 5 equals 100,000. Okay, so having this little list will always also help you. Okay, good luck. The exercises are pretty good for this one. There's not too many to do, so have a go at them, see how you go, and if you need extra help, I can help you during the scheduled lesson time. Okay.